So I finally figured out how we can get this thing to work as far as sweeping a minefield. The issue I've been having is we've been using um, something called the Global Planner, and basically it uses a pathfinding algorithm to find a path from where we are currently to the goal. And so you get all the, it makes it difficult for it to just make a sweeping pattern. And so what we need is something way simpler than this. But I wanted to keep this local planner and this all the rest of the move base system. And so one of the ways you can do that is by writing a plugin. The hard part is just getting it to compile and getting all the settings right. But the code's really easy. So I was using this guy over here, which was essentially just using Dijkstra's algorithm applied to a grid space. Now we got this local planner, which I just got done writing. Um, and so it basically plugs into the rest of the move base system. And so this is the code. It's the MS Global Planner, or just Minesweep Global Planner. The header file is really short. It's just basically, for it to be a plugin, you just inherit from this class right here, and then you have to override these two functions. And assuming you do everything correctly and you register the plugin, you'll be able to use it. And so I figured that out today. As far as the implementation, for now, I mean, the constructor is empty. That's just a different version of the constructor. The only thing I'm doing is I'm just advertising this plan so that we can see it in RViz, because it's actually the way it gets sent to MoveBase in this plugin API, it's not really something that you can see unless you explicitly publish the plan as a visual marker. And so then you just have to override this make plan function, and it has as inputs a start and a goal. And so these are just positions. And then you have the output is a vector of positions, which is the plan. And so you'll notice that I create this thing called nav messages path, and this is just the same thing as this. It's just this version you can publish, and then you can see it. And so you'll see that I push back the new goal, which at first I just set it to wherever the robot is, and then I set the path header equal to the start header so that they're in the same coordinate system and everything. And then you just say, plan.pushback, then path.pushback. And then for right now, I'm just going in a straight line for 19 meters, because I screwed up and I made the actual grid that you see, it's only 19 by 19. I don't know how that happened, but so right now it's just going to go straight for 19 meters, and every 5 centimeters it's going to put a new position into this path or plan. And then publish the path, which is the visual marker, and then the plan is actually passed in by reference, so that goes back to the MoveBase system. So this is actually pretty simple code-wise. It was just difficult to set up on the configuration side. And so you'll notice that in my implementation I didn't reference the goal at all, so it doesn't matter where you click, it's just going to start this pre-planned path, so to speak. So it'll go forwards for 19 meters. And yeah, our robot spits rainbows now. These are all the possible path vectors it could take, and it's always just going to select the one that's best for it. But it's just something interesting to look at. And because I haven't told it to do anything else, it's just going to keep going. So in this way, we can make the robot drive really straight lines that are pre-planned, assuming that we have these two map points. Alright, that's it. Take it easy.